Hi again. So in this third tutorial, we're going to look at the jit.gl.multiple object, which allows us to have multiple instances of a GL shape that we've already created. I'm going to be building off of the same patch that we've built in the second video. If it looks a little bit different to you, it's just because I've reorganized things a little bit so it looks cleaner. But we have basically the same things. I'm going to do a super quick recap where here in the top left corner, we're creating our jit.world and sending the bang at every frame. Over here, we are loading a movie from our hard drive and setting it onto a texture that's called text movie. We have the jit.gl.grid shape, which is creating the geometry that we want to apply the texture to. We have the jit.gl.mesh, which is taking in the geometry from grid shape and applying the texture onto it. And last but not least, we have the sound file that we took from the Max default sounds, turns into a matrix, and we are mixing that matrix with the shape generated by jit.gl.gridShape in order to trigger these alterations to the mesh based on the sound. Um, so what we're going to do in this tutorial is make more of these shapes on a grid and see where we can go from there. Um, so the object that we're going to use, as I was mentioning, is jit.gl.multiple. Oops. And just like most other jit.gl objects, the first parameter is the name of our world, which in this case is going to be RTM. Um, oh, I should mention I'm like freestyling this tutorial a little bit, so if I get stuck, please just bear with me. All right, so jit.gl.multiple, we have the name of our world, and in order to give it a shape to work with, we are going to be using names, kind of in a similar way that we set a texture with a certain name and then use that name inside of jit.gl.mesh. In this case, we want the multiple to be the mesh that we've just created. So we're going to give it a name. So let's just call it cool mesh. And you see, just like reset the view and the properties, but that's fine. We can deal with it later. And in here, we're going to use the target name parameter and tell it that the target is cool mesh. All right. We don't see anything just yet, right? Like we just have our one mesh that we've set up and that's fine. If you look at this object, it has two inlets. The first one is saying matrix position array, and the second one is saying matrix scale array. Position and scale refer to where all of the objects that the jit.gl.multiple, like all of the objects that jit.gl.multiple is generating, they're all going to have their own positions and their own scales. And we need to specify those using matrices. They're the same kinds of matrices that we've been using for noise, or that videos get fed into, or that our sound visualization is fed into. And the way these matrices work is that, or like the way they work in the context of jit.gl multiple, for the position, we need matrices with three planes. The first plane is for the x coordinate, the second plane is for the y coordinate, and the third one for the z coordinate. And the number of elements in the matrix is going to correspond to the number of meshes that we want to spawn, right? So if we create a matrix, let's see, jit.matrix, we said three planes. I forgot to mention the type of them should be float 32. And then let's say we want to generate like a grid of 5 by 5 of our meshes. Of course, we first need to populate this matrix with the positions of the of all 25 elements before plugging it in. But that's going to be the shape of our matrix. And then we're going to create a similar one for scale, jit dot matrix, three planes again, and in this case they're going to be the scale for the x, y, and z axis. Float 32 is the data type, and then again they're going to be 5 by 5 matrices. At this point I should mention there's another property on the jit.gl.multiple object that's called dim param. And this one specifies basically the shape of our matrices. So in this case, it's going to be 5 by 5, right? It's where we're going to have 25 objects. Great. Now we just need to populate our matrices with the positions of the objects, and then we're going to, with the positions and with the scales, and then plug them into the jit.gl.multiple object, and hopefully see them on the screen. I'm just going to zoom out a little bit and zoom back in so I have a little bit more real estate. Great. So let's think a little bit. Let's say we want our meshes to be placed in a square of 5 by 5. Maybe at position. Let's just use two axes for simplicity. So say all 25 of our meshes are going to have the z equal to 0, and then the x and y, maybe we're going to start at 0, 0, and then another one will be at 0, 1. Well, maybe I should say 0, 0, and the z is 0. 0, 1, 0, and so on until 0, 4, 0, and then the same way going down until we get to 4, 0, 0. 4, 1, 0. Oh my god, so difficult. Dot, dot, dot. 4, 4, 0. Right, so we're just going to put them on a grid. And we need to populate our matrix in a way that reflects that, right? So the first plane needs to be the x-coordinate for all of these squares. So 0 for the first row, 1 for the second row, 2 for the third row, and so on. The second plane needs to be the y-coordinate, which is going to be 0 for the first column, 1 for the second column, and so on. And the third plane is going to be 0 for all of them because they're all going to be on the same z-axis. Right, one way to create this this kind of like grid layout is by using a few USI objects. I don't know if you're familiar with the USI object. It's basically an object that triggers as many bangs as the parameter you give it, or as many bangs as you give it into the second inlet. And it's kind of a way of emulating a for loop, right? Like in P5 or in JavaScript, we have the power of the for loop. In Max, for doesn't really exist, but we can go around that using the USI. The first outlet of the USI triggers each one of the bangs, right? So in this case, it's going to be 5 of them. The second one triggers when the bang is done. I'm not exactly sure how that works, but we're not going to use it. And the third one outputs the current index of the USI. So let's try this out. We send it a bang. Let's have a bang here for debug, and maybe an int to look at the indices. So I'm going to trigger it. We only see the 5 because the USI went by super quickly, but like the 5 USIs went by super quickly, but their indices are 1, 2, 3, 4, 5. Our matrix, however, is 0 indexed, so in order to access the row using this USI, we're going to subtract 1 from the index. So we can do that by just typing n for an object and then typing -1. Um, and this is going to be the index of our row, right? And now we need to nest another Uzi inside of this one in order to get an index for the column, and then set the coordinates for X, Y, and Z for each one of the 25 squares. So I'm going to create another Uzi of size 5. Oops, oh no. All right, there we go. Another Uzi of size 5. I'm going to connect it to the first one. So each of the 5 bands from the first one is going to trigger another 5 bands. We need to subtract 1 from the second index again. Um, and now we should have basically 2 nested for loops that go from 0 to 5 and from 0 to 5 in order to traverse our matrix. And we're going to use the set cell message for the matrix. This one takes the row, the column, and then for the value, we can specify the value for each one of the planes, right? And we have 3 planes, so we need to give it 3 numbers for the value. I'm just going to do 3, 4, and 5, and we're going to revisit that in a second. All right, so 1 and 2 are the row and column that we want to deal with, and we have them coming from Uzi, right? So we're going to need a pack object in order to be able to pass multiple values to our message. So I'm going to create a pack object, and for now I'm just going to have 2 integers, and the first one is going to be, let's see, the first one should be the column, not the row, because the pack object updates whenever the first inlet updates. And then the second one is going to be the row. Okay, this looks a little messy, but that's okay. And if we plug this into our message, we have parameters number 1 and number 2, right? And these are going to be 0, 0, 0, 1, 0, 2, 0, 3, and so on and so forth until traversing the whole matrix is complete. Now we want to set the values for X, Y, and Z. We've established already that for each one of the 25 meshes, the Z is going to be 0, so we can just replace this with 0. And for the sake of simplicity, we can just, like we were saying, we're going to place them at 0, 0, 0, 1 up to 0, 4, and then on the other axis 4, 0, 4, 1 up to 4, 4. So we could actually simply use the indices of the matrix as the position as well. And I'm going to print this matrix in a second in order to actually see what's going on in there. 1 and 2. And then we're going to pass this message onto our matrix, and that should be it, I believe. Let's see. Let's look at what we've done. There is an object in Max that's called jit.gl.multiple. And this one allows us to visualize the matrix. It's actually quite neat. We can look at the values inside of it. So if we connect the matrix to our cell block and hit the bang, I have no idea what's going to happen. I'm super scared, but I'm gonna do it. I'm doing it. Okay, nothing happens. That's not great. All right, let's see. Oh, I see. Sometimes Max wants you to bang into the matrix. Yeah, Max wants you to bang into the matrix as well. I'm not sure if I'm doing something wrong or yeah, but there we go. We have the first plane. So the JIT cell block object by default shows only the first plane, but we can look at the other planes as well by using the plane message. Let's see, let's give it an integer. Make them a little bit more neat. Okay, so this is the X plane, right? And we have kind of what we were expecting, right? Like there's five of the meshes with an x of 0, five of them with an x of 1, five of them with an x of 2, and so on, right? So it's like one side of the grid. If we move on to the y plane, we see that five of them have a y of 0, five of them have a y of 1, and so on, right? So by having this configuration, we should have them arranged in a grid. And if we go to the z-plane, everything is 0, right? Because we told it to have to make the z 0 for everything. All right, so we have our first matrix, the position matrix. And now we need to set up the scale matrix as well. Fortunately, this is going to be way simpler because we want the scale to be uniform, right? Like we want everything to have the same scale. So we just need to create a matrix that has 25 of the same value on 3 planes. And we can do that by using, there's this object called jit.expr from expression. It's a super powerful object. It allows you to kind of like programmatically set the contents of a matrix. There's lots and lots and lots of things you can do with it. I'm vaguely familiar with it, and we're only going to use one really simple functionality of it. We're going to use the expr parameter, and its value is going to be in of 1. What this means is that the expression takes a matrix as an input and a number into its second inlet, and the output of the expression is going to be the matrix that came into its first inlet with every one of its values set to the value that we provided in the second inlet. So let's print it again using a cell block. I'm going to zoom out again and make some more space. Let's rearrange this a little bit. Okay, let's see, and we're going to need the band. Okay, so right now everything is 0 because we gave it a value of 0. Let's start with a scale of somewhere around 0.5 and bang again, and we see that our value is updated to 0.5. I think Max is just rounding 0.495 to 0.5. Let's do one more thing. Let's make it such that whenever we update our value, the matrix updates as well, just so we can kind of real-time update the scale of what we're going to see on screen. We can do that by triggering a bang every time the value is changed and plugging that bang into the matrix. Again, I think this is a hack. There might be a better solution, but this is just how I got it working. So let's see. We're going to use the trigger object, say trigger bang. Every time the value changes, we call the trigger bang. And we plug this right back into our matrix. I'm going to hit Command Y to arrange this wire. And now, whenever we change our value, we should see the values in the output updating as well. All right, so now we should technically be ready to plug this into our scale of the jit.gl.multiple. And still nothing happened. We need to figure out why. we still have our original mesh. Oh, one thing that we should do is make the original mesh disappear, right? Because we only want to display our grids of meshes that we've created using this shape rather than having the first one. The way to do that is by setting the automatic parameter to 0, and that just disables rendering it on the screen. All right, so now if we zoom out a little bit, oh, interesting, the mesh is still showing up. Let's change it to 1. Oh, I see. It's looking like we have more of them. I see. So we're probably getting some meshes from jit.gl.multiple, but they're not behaving the way we want them to, and also the original one. So I'm going to disable the original one, and I assume this one is coming from jit.gl.multiple. All right, so now let's figure out why we only have one. Huh? Oh, there we go. Okay, I just needed to update the matrix. I've realized making this tutorial and like in preparing for it that the jit.gl.multiple object is kind of iffy. Sometimes you need to reload the matrices. I've also had to quit Max and restart it at some point when my meshes were not showing up. So just keep that in mind. If something is not working, it might be your fault, but it might also be the fault of the object. So as we can see, we have a grid of 5 by 5 um, toruses here that are all playing our video texture and responding to the sound. Let me just change the angle a little bit here. All right. One more thing we could do at this point is maybe play a little bit with the display mode. I kind of like the triangle strip one. I think it looks pretty fun. And then we could zoom in a little bit. I think my computer is having trouble running the recording software and Max at the same time. But you get the point, right? So we have a grid of 25 of them, and if we do adjust the value over here, the scale one, you'll see that all of them are going to change their scale, right? Like we can make them real tiny, we can make them real big, and now it's just a huge mess of stripes. Let's settle somewhere around like 0.2 maybe. Yeah, maybe a little bit more. 0.3 should work. All right. I want to show one more thing before wrapping up this tutorial, and that is kind of automatically adjusting the scale of our shapes based on a different variable. So in this case, we're just going to set up a drunk object in order to kind of randomly grow and shrink the scale of all of our toruses. So if you remember, oops, I need to unlock my patch. There's the drunk object, which takes as a parameter, it takes two parameters. The first one is the maximum range, the maximum value, and we can just work with 100. And the second one is the size of a step, and the size of a step from frame to frame. I'm going to use 5. And we need to send the bang into it every time we want a new value. In our case, that's going to be at every frame. So we can use the receive draw and plug it in. And then for now, we can just print the output of the drunk into an integer. So we see it's kind of going, yeah, doing a random walk basically on these numbers. Maybe we can reduce the range to 3. So the changes are a little smoother. Okay, so now what we want to do is to adjust the range of this value from 0 to 100 into something that could work for our scale, which is probably between 0 and 1. Right, so we can just do, I'm going to keep this here just to make sure that the object is working. All we need to do is divide the result of this by 100, and then we're going to plug it into our parameter here and observe the scale of everything changing in real time. So I'm going to do division by 100.0 just because we want a float division. I'm also just going to add a float here so we can see the result and make sure it's what we need. And then I'm going to plug this into our scale parameter. Right, so now you should see the scale of our torus is changing based on the value of the drug. And I'm hoping this is going to give you ideas around how you can manipulate this using maybe values from a matrix, right? From an image or from sound or from your webcam or anything else, right? Like the world is your oyster.